Hello, welcome to TechWebDots. Today I am going to discuss code constraints which are applicable on Azure orchestration functions especially. Let's go ahead without wasting time. So, all the green sections I have already covered in my previous recorded session. I strongly recommend you to watch that, and the highlighted one I am going to discuss today, and all the white one I will cover in my upcoming videos. Now, there are some prerequisites that I strongly recommend you to take a pause of this screen and read out thoroughly. And the very important things are Azure Development Workload, Azure Emulator and Azure Storage Explorer should be installed on your machine. That will help you definitely to understand all these concepts. And I strongly suggest you to watch the previous recorded videos, for example on Azure Functions, Durable Functions and Solid Design Principles. Okay, now before moving ahead for code constraint, I strongly wanna give you a brief about durable functions, which is an extension of Azure Functions. The extension lets you define a stateful workflows by writing a stateful orchestration of function execution within function app. You can use an orchestration function to orchestrate the execution of other durable function within a function app. Orchestrator functions are stateful, reliable, and potentially long-running functions. And there are currently 4 durable function types that I have already discussed in detail in my previous sessions. And these are orchestrator, activity, entity, and client function. But there are certain constraints which are applicable on orchestrator function. So let's understand them one by one. Okay, so this is the example that I have discussed earlier as well of orchestrator function. Here we are calling different activities, for example F1, F2, F3, and in some of them we are passing input as well, X, Y, Z. Okay, so important points about orchestrator functions are orchestrator functions describe how actions are executed and the order in which actions are executed as shown in different patterns we have already seen. Using an orchestration trigger binding to define an orchestrator function. Then there is one important note, orchestrator functions are written using ordinary code, but there are strict requirements on how to write the code. Remember, we are saying a strict requirement. Specifically, orchestrator function code must be deterministic. Now you must be thinking about what actually deterministic means. So we will discuss in detail in next slide. And failing to follow these determinism requirements can cause orchestrator functions to fail to run correctly. Okay, so that's why these constraints are very important to understand. This is my Visual Studio and I am using the same solution that I have already used in my all previous sessions. And as you have already seen, I have discussed all these patterns, right? But I have selected for now async HTTP API pattern. And I would like to discuss a typical structure when you will create any durable function. So the moment you create durable function, you must be having one client function or maybe other mean to call your orchestration function, which looks like this. So first the client function which contains your durable client. Okay, this is of type HTTP that we can call. Second is orchestrator function which contains orchestrator trigger, and third one is activity function, or this is the version 2 of activity function because previously we discussed activity function like this where we just pass simply an input parameter name and just use it. Another way is we can use the iDurable activity context as a parameter, and whatever information that you are passing to this activity function that we can get through activity function dot get input. If you are passing a name to this activity trigger function, so you can just use like this get input of a string, so that will be fetched by this activity context get input method, and you can directly use in this way. This is better way when you are dealing with a complex structure. When I say complex means when you are creating your own classes, own properties, own method and dealing with own data. Okay, this is one thing. One more type of function which is entity function that we have already discussed in our aggregator pattern. Orchestrator functions uses event sourcing to ensure reliable execution and maintain local variable state. The replay behavior of orchestrator code creates constraints on the type of code that you can write in orchestrator function. Now you must be thinking event sourcing, local variable state, and replay behavior. What is this? When we actually use durable function, so that function executed several times for the life cycle of its execution. So that's why replay is important. And what is the meaning of deterministic, you must be thinking? So an orchestrator function will be replayed multiple times and it must produce the same result each time. Okay, this is very important. It must produce the same result each time. Only then we can say our function is behaving as deterministic function. Okay, and there are certain areas that we should take care. For example, one of them is using deterministic APIs. Orchestrator functions can call any API in their target language. However, it is important that orchestrator function call only deterministic API. Deterministic means every time it is returning the same value. That helps to ensure that your function code is deterministic. A deterministic API is an API that always returns the same value with the given same input, no matter when or how and often it is called. Some APIs pattern that you should avoid because they are not deterministic. Okay, these restrictions apply only to orchestrator function. These restrictions are not applicable to entity, not applicable to activity. Okay, other function types don't have such restrictions. And there is one important note: several types of code constraints are described, but this list is unfortunately not comprehensive. By saying not comprehensive means there can be many other scenarios that should be taken care, and some use cases might not be covered. Okay, so what are the other areas where that we can think of? Dates and times. API that return current date or time are non-deterministic and should never be used, but there is always a way how we can use them. This is because orchestration function replay will produce the different value. You should instead use durable function equivalent API for getting the current date or time, which remains consistent across replays. So in C Sharp, we should not use datetime.now or datetime.utc_now or equivalent API for getting the current date time. Classes such as stopwatch should also be avoided. For .NET in-process orchestrator function, what you can use iDurable orchestration context .current UTC date time property to get the current date time. And for .NET isolated orchestrator functions, you can use task orchestrator context .current date time UTC property to get the current date time. So how you can use in a very simple way? Date time you can use context.current UTC date time, and if you want to just calculate the time, so you can just use the subtract method and you can provide the time as well. So this is another part where you should take care when you are writing orchestrator function. Now GUID and UUIDs. API that returns random GUID or UUID are non-deterministic because the generated value is different for each replay. Depending upon which language you use, a built-in API for generating deterministic GUID or UUID may be available. Otherwise, use an activity function to return a randomly generated GUID or UUID because those values can be saved and can work in replay in the expected manner. So in C Sharp, do not use API like GUID.newGUID to generate random GUID. Instead, you can use the context object, which is new GUID API, to generate a random GUID that is safe for orchestration replay. So in this way, you can just use context.newGUID. GUIDs generated with orchestration context API are type 5 GUIDs. So let's have a look in Visual Studio how they look like if you write and where to write these concepts. Okay, when you are writing your orchestrator function, so if you want to use context.current date time, UTC date time. So you can use it like this and use this time. This is safe for replay as well. In the same way, the correct way of using GUID is you can call context.new GUID. So this variable can be used as a system.GUID. Okay, that way you can use. So you need to take care of these things. These are really helpful. Let's go back to the presentation. So what are the other concepts? Random numbers. Use an activity function to return random numbers to an orchestrator function. The return value of activity functions are always safe for replays because they are saved into orchestration history. Alternatively, a random number generator with a fixed seed value can be used directly in orchestrator function. This approach is safe as long as the same sequence of numbers is generated for each orchestration replay. Another part is binding. An orchestration function must not use any bindings, including even the orchestration client binding and entity client binding. Always use input and output binding from within a client or a activity function. This is important because orchestrator function may be replayed multiple times just to calculate the behavior or the different functions values, causing non-deterministic and duplicate input output with external systems. Okay, the next part is use of static variables. Avoid using static variables in orchestrator functions because their values can change over time and resulting in a non-deterministic runtime behavior that we really should avoid when we are writing orchestrator function. Instead, use constant or limit use of static variables to an activity functions only. Note, even outside of orchestrator function, using static variables in Azure function can be problematic for a variety of reasons since there is no guarantee that static state will persist across multiple function execution. Static variables should be avoided except in very specific use cases such as best effort in memory caching or in activity or entity function. Another important part is environment variables. Do not use environment variables in orchestrator function. Their values can change over time, resulting in non-deterministic runtime behavior. If an orchestrator function needs configuration that is defined in an environment variable, you must pass the configuration value in orchestrator function as an input or as a return value of an activity function. Network and HTTP use activity functions to make outbound network calls. If you need to make an HTTP call from your orchestrator function, you also can use the durable HTTP APIs. I've already discussed this pattern in my previous recorded videos, so I strongly recommend you to check out the playlist link which is given in the description of this video. Now another part is thread blocking APIs. It is very important. Blocking APIs like sleep can cause performance and scale problems for orchestrator functions and should be avoided. In the Azure function consumption plan, they can even result in unnecessary execution time changes. Use alternatives to blocking APIs when they are available. For example, you can use durable timers to create delays that are safe for replay and don't count towards the execution time of an orchestrator function. So in this way you can save some money as well. Async APIs. This pattern is already discussed, but orchestration code must never start any async operation except those defined by the orchestration trigger context. For example, you should never use task.run, task.delay, and HTTP client dot send async in .NET or set timeout or set interval in JavaScript. So these are the points that you should take care when you are writing orchestrator function. An orchestrator function should only use async work using durable SDK API like scheduling activity functions, and any other type of async invocations should be done inside activity functions, not in orchestrator functions. Okay, so I hope it is clear now. There are a few more points like .NET Threading API. The durable task framework run orchestrator code in a single thread. Okay, remember, single thread, and can't interact with any other thread. Running async continuations on a worker pool thread, an orchestrator's execution can result in non-deterministic execution or deadlock. For this reason, orchestrator functions should almost never use threading APIs. For example, never use configure await, in which you can just continue on capture context pass. In this way is an orchestrator function. This ensures that the task continuation run on the orchestrator functions originally synchronization context. Okay, so this is what that you should always remember. And there is a note: durable task framework attempt to detect the accidental use of non-orchestrator thread in the orchestrator function, which is good thing. But if it is finds a violation, then the framework throws a non-deterministic. However, this detection behavior wouldn't catch all the violations, it not depend on it. Next is versioning. A durable orchestration might run continuously for days, months, year, or even eternally. So any code update made to the durable function app that affect unfinished orchestration might break the orchestration replay behavior. So you should take care of that. That is why it is important to plan carefully when making updates to the Azure Functions code. Okay, now the last one, and it is very important one, durable task. This section describes internal implementation detail of durable task framework, which is used in every durable function. It is intended to help you to understand the replay behavior, and which is very important. Tasks that can safely wait in orchestrator function are occasionally referred as durable task, and the durable task framework creates and manage these tasks. Examples are task written by call activity async, wait for external event. We have used these functions in our different patterns, and create timer in .NET orchestrator function. These durable tasks are internally managed by a list of task completion source object in .NET. During replays, these tasks are created as part of the orchestration code execution. They are finished as the dispatcher enumerates the corresponding history events. Okay, this is very important point. The tasks are executed synchronously using a single thread until all the history has been replayed and completed. During tasks that are not finished by the end of history replayed, have appropriate action carried out and checked later. For example, a message might be enqueued to call an activity function, and later we will call the activity function. To understand why orchestrator functions can't use, await, or yield on a non-durable task. Okay, so there are two reasons. The dispatcher thread can't wait for the task to finish. This is one thing. And second thing is, any callback by that task might potentially corrupt the tracking state of orchestrator function. So these are the all points which are important while you are writing the orchestrator function. So I hope you like the video. If you have any question, any suggestion, you can leave into the comment box, and I strongly recommend you to give your feedback. That's the only inspiration for me to create such videos, and I will see you in the next video where we will discuss error handling. Till then, bye bye, take care.